Before you start chapter 5, it would be really helpful to know some stuff about uh, exponents and how to work with them. So if you want to try these couple problems before I go over them, feel free. Pause now and try the problems first so we can check. All right, well, there's a couple rules that you need to know about exponents. One is if you have two numbers with the same base, like for instance, if I had a to the second times a to the fifth, I would add those exponents together to make a to the seventh, because you got two a's here and five a's here. That makes seven a's. So in multiplying two numbers with the same base, you add the exponents. When you have a power to a power, like for instance, b to the third to the second, you multiply the base, multiply the exponents, because this is the same as b to the third times b to the third. So of course, you add 3 plus 3. In this case, you do 3 times 2. And another important, there are a couple more important things to know about exponents. We'll get to those in a second. So the problems that I have here, 3 times 10, they're not exponents, so that's just 30, x to the seventh. This one here, 3y to the third times 3y to the third times 3y to the third times 3y to the third. In other words, 3 is being taken to the fourth power. 3 to the fourth is 81. Y to the third to the fourth is y to the 12th. Now, you might have said to yourself, if I have 3 to the first to the fourth, I can write that as 3 to the fourth, which is true. That's what 81 is. In this problem, we have two things going on. First, we're going to use order of operations, which means we're going to do the exponents first. In other words, we're going to leave the 4z to the fourth alone for a second, and then we're going to multiply this stuff out. So 2z to the third would be 2 to the third, which is 8, z to the third, which is 9, z to the ninth. Now we can multiply these things together. Negative 4 times 8 is negative 32. And we have z to the fourth times z to the ninth. Applying the first rule, we add those exponents together, z to the 13th. All right. Those are the first parts of exponents. Let's try these couple. Try these three. Pause and try these three. So we have two different types of things going on here. One is division. When you're dividing two numbers with the same base, like a to the eighth over a to the second, you subtract the exponents, because you're basically having 8 a's on the top, I don't know how many I can get, over 2 a's, which means that 2 of them are going to cross out. If you cross out 2 of them, you're left with 6 on top. If there had been more in the bottom, like in this other case, the second case, then we would have more left on the bottom. So for instance, end of the third over the end of the seventh would be end of the fourth in the denominator. Now, if you use the same rule as what we have in the numerator, you'd say end of the third minus, subtract the exponents, 3 minus 7, and you'd have end of the fourth, negative fourth. End of the negative fourth on top is the same as end of the positive fourth on the bottom. That's one of the rules about exponents that you need to know. By the way, 2 over negative 10 don't happen to be exponents, but we can reduce those just like we reduce any fraction. Now, this business about end of the negative fourth gives you some insight into what this is. 2 to the negative third is the same as the reciprocal of 2 to the third. In other words, 1 over 8. We should be able to have that kind of situation going on. Now, if you're not quite sure about the negative exponent business, then let's take a look and see how that works. One of the examples I would give would be 2 to the third, 2 to the second, 2 to the first, 2 to the 0, 2 to the negative 1. See what's going on. Another 2 to the third is 8, and 2 to the second is 4, and 2 to the first is 2. You know, if you're multiplying, you're going up and multiplying by number 2. But if you're going the other way, it's dividing. So for instance, 8 divided by 2 is 4, and 4 divided by 2 is 2. So using that logic, I would say that 2 divided by 2 is 0. 2 to the 0 power is 1, because 2 divided by 2 is 1. Think about it. If I multiply and go upwards, I'm dividing by going downwards. So 8, 4, 2, 1 makes sense. Just like 8, 4, 2, 1, 1/2 makes sense, because this is the reciprocal of 2 to the first. And 2 to the third, 2 to the negative third that we had is the reciprocal of 2 to the positive third, which is 8. So those are a couple rules about exponents that you need to know. Let's see if I have any more in here. Oh, let's try that one. So that implies that uses all of the exponent rules. So try that one first, and then we can work it out. So I'm going to work this out by first getting rid of the -2 power. And I can do that by either taking the reciprocal of that whole mess or just using the power to a power rule, which I think I'll do first. I'm going to keep everything the same for a second here because I don't want to rock the boat. So I'm going to say -7 to the -2 power. Now, -7 to the -2 power is the reciprocal of -7 to the +2 power. -7 to the +2 power is 49, so this must be the reciprocal of 49. So I'm going to put 49 in the denominator because of this -7. -7 to the -2 power. A to the third to the -2 power. I could just multiply those together, or I could put it in the bottom, but I'll do that in a second. So 3 times -2, and b to the -1 times the -2 is b to the +2. Now I could have done this differently, but I'm just doing it this way because I think it might be easier. So now I'm going to take a look at all the different parts of this function or this problem separately. So for instance, I'm going to take a look at the number parts. So I've got a 4 in the top, I've got a 2 in the bottom, and I've got a 49 in the bottom. You don't have to do it like this. I'm just trying to make it easier. And I'm going to take a look at all the a's. I've got a on the top over here, and I've got a to the -6th. Well, a to the -6th is the same as a to the +6 in the bottom. So I'm going to put this one down the bottom. And there's an a to the 5th already in the bottom. So I'm going to put that one there too. So making the exponents positive at this point by changing them around is helpful, I think. Now I'm going to look at the b's. Let's see, we have a b to the second on the top and another b to the second on the top. And I've got b to the -3rd in the denominator. B to the -3rd in the denominator is the same as having b to the +3rd in the numerator. So let's do it that way. Now I think we can gather up the answers. 4 divided by 2 is 2, so I'm going to end up with 2 on the top and 49 on the bottom. Okay, can't do anything with that. But look at all these a's. I've got 1 a on the top and 11 a's in the bottom. I can subtract, but there's more in the bottom, so I'm going to have 10 left over in the bottom. 5 plus 6 is 11, minus the 1 from the top. There's nothing on the bottom of these, so it's just 2 plus 2 plus 3, which is 7. So 2b to the 7th over 49 a to the 10th is this whole mess. Obviously, there are other ways of going about it, but make sure you do exponents first, which is this mess in here, and then figure out what you're going to do to simplify.